Thank you very much and happy to be here. So today I want to share a little bit of what we do in terms of Amazon and Amazon Web Services around sustainability and renewables. I want to look a little bit into how we can build digital platforms in a more sustainable manner, and specifically how cloud computing can help us do that. And then we end up with a few examples of some of our customers. But if we talk sustainability, there are actually a lot of elements to sustainability. Today I will primarily focus of course, on the topic of energy. And so we're going to have a look at first the infrastructure on which we're building. And I'll share a little bit what Amazon as a whole is doing and how you can benefit from using, for example, our platform. But more specifically, how you can also utilize it effectively and then build intelligent buildings on top of it. But to kick it off, let's have a quick look at what Amazon as a whole is doing. And when I say Amazon as a whole, it's not just AWS, which is Amazon Web Services, which I would represent, but the whole of Amazon. So anything around retail, Amazon.com, Amazon.in, etc. We're looking into how can we actually achieve the Paris Agreement 10 years early. So that was our commitment. We called it the Climate Pledge. We announced that in September 2019. And the idea is can we be 100% net carbon neutral by 2040. Actually, we set the target also in terms of renewables to say by 2024, we want to be running on 80% renewable energy. By 2025, 100% on renewable energy. And again, this is not just AWS, but all of Amazon. And also we're looking into how can we make our shipments, which is a big challenge for a company like Amazon. How can we bring shipments to zero carbon neutral by 2030? So what do we do? For example, if you take the retail space before jumping into AWS and our platform, we're looking, for example, to take our Amazon fulfillment centers and, of course, power them to solar, basically install solar power panels on all the roofings of those fulfillment centers. In addition to that, we're looking into how can we make use of electric vehicles. You might have seen that we recently just launched in Los Angeles, actually, our prime EVs, our electric vehicles, to do electric vehicles for delivery. But let's talk a bit about energy, and this is specifically important also when we look into AWS. So by 2025, our target is to be 100% on renewable energy. How do we achieve that? Obviously through solar, obviously through wind farms that we're building. Currently we have about 127 renewable energy projects all across the world with an overall power generation of 6.5 gigawatt when they're all operational. So that's 18 million megawatt hours annually, which as of last year made Amazon the largest corporate purchaser of renewable energy. And we're not going to stop there because we're going to achieve that target by 2025. And obviously, as I go into the platform now, you as a consumer can obviously rely on us to actually use renewable energies for any of your IT infrastructure that you're using. I said it's not just energy when we talk about sustainability. Another thing that we're looking at is how can we, for example, reduce the amount of water that we consume. If you ever looked into data center facilities, you can cool them through air, but also through water cooling. And our idea here is, can we cool it with water without actually wasting fresh water supplies? So we're looking into things like evaporative cooling, reduce the amount of potable water usage, recycle the water. And you can see some pictures there of these pipes that basically recycle the water within our data center facilities. But let's stick with data center facilities for a moment, because obviously if you're looking into making your buildings more intelligent, or as a company as a whole, and COVID has probably, or the current ongoing pandemic has transformed a lot of companies to go fully digital. So we need an IT platform, right? And that runs on services, runs on data centers, that runs obviously on the cloud, right? But if I run on the cloud, it's still AWS who maintains data center facilities. However, what we have found is with all the investments that we do into running our facilities efficiently, into some of the things around chipsets that we manufacture, in which I will get to in a bit, we actually found that compared, and this was research done in the US, but probably globally it's roughly similar, compared to an enterprise data center of average enterprise companies out there, will find that we are a lot more efficient when we run it in our AWS data center. Specifically, we found that up to 3.6 times we are more energy efficient, which actually allows us to be up to 88% reducing the amount of carbon emissions that we have just by running these servers. Why is that? Well, it's all about utilization rates. So you find when you run a data center, you're looking into, well, how can I find a nice granularity between having enough capacity to run my application, but at the same time don't have underutilized servers. We actually found that in average, the US enterprises that run their own data centers only have a utilization rate of about 18%, which is actually really not great. So we're looking into how we can do that better. Now, if you use AWS as a platform as a whole, you benefit from those efficiencies. We find that in average, you have 77% fewer servers that you're actually running just based on having a better utilization rate, and I'll show in a minute how you can do that, but as such also consume less power, and as such reduce the carbon footprint that you're emitting. Now, I talk about efficiencies that we do in a data center. So it's not just about us running it efficient in terms of looking at utilization rates, but we're also investing into the actual chipsets that we manufacture to run in those data center facilities. So we give our customers full choice, so no matter if you want Intel or AMD chipsets, or you want the latest macOS, but more importantly, I want to focus on something called Graviton 2. Graviton 2 are actually ARM-based processors that AWS manufactures themselves. And why do we do that? Because it allows us to build more energy efficient CPUs that you then as an end consumer can use for your digital projects. To put that a little bit into perspective, you can see here on the picture, this came actually from a keynote last year where our VP of Global Infrastructure is explaining how Graviton 2 can be used as an ARM-based processor, which is much more power efficient, actually in comparison to some of the general, this I think was an Intel CPU that we're comparing it against here, was dramatically more power efficient on the CPU cores. Right? And that obviously allows us to run applications a lot more energy efficient. But talking about that, you know, that's kind of the baseline in terms of infrastructure and how we can make it more efficient. Now, obviously, if I want to consume cloud services as an end consumer, I don't really want to care about that, right? That's AWS's role in business to do that for you. But let's talk about effective utilization. When I mentioned earlier, you know, a lot of data centers don't really run efficiently. Why is that? Well, think about demand and capacity, right? And specifically for an IT platform. Any digital service that you offer needs to obviously cope for the incoming demand. Now, what you can do is you can say, I predict my user base and my platform is growing over time, you know, with a certain prediction, and then I go and buy and rack and stack traditional hardware and servers and capacity and network switches to be able to meet that demand. Now, the reality is that very often the actual demand varies greatly from what you predicted in terms of the demand, and that either way is then wasted resources in terms of having over-procured and running resources unnecessarily, which obviously consumes electricity, or if you have too little resources, you know, you can't match the demand. So the idea is can we actually get to a scenario where I as a consumer don't need to worry about capacity, where everything automatically would scale. And, you know, talking about utility, that's a perfect analogy. If I switch on my light, I don't really care, you know, how much electricity I consume or not. It just automatically will be the right amount. We want to do the same when it comes to digital platforms for IT services. For anything you can consume, we have auto-scaling capabilities. That's one of the main reasons folks move to cloud computing, because you have elastic capacity and you only consume what you actually need for your services. How does that work? Well, that's a concept. If you're in the IT space, you might have heard of a concept called serverless. Now, that obviously does not mean that it doesn't run on servers, but what it means is that you as an end consumer don't need to worry about provisioning infrastructure or scaling that infrastructure out or thinking about how do I make it highly available or secure it. It means that you only pay for what you actually really use, and as such, only consume the amount of electricity that you only use for your platform. And when I'm talking serverless, this is not just about compute, right? If I need to run a platform, I need computational services, but it's also databases, messaging services. Maybe I run analytics or machine learning services. You know, for cloud providers like AWS, they provide you a full spectrum of saying, choose the services that you want to use, consume only when you want to consume it, and that allows us to run very energy efficient in that regard, only basically provide you with what you need when you need it. All right, so that's kind of around utilization. Now, the other thing is when we talk about smart buildings, for example, what can we do to intelligently manage our buildings and basically use data and sensors and IoT maybe to reduce the amount of energy that we consume within a facility. And now the good news is, the IoT, which has been talked about for many years, is a complete reality. Most buildings by now, especially newer built buildings, have lots of different sensors and devices, from cameras, temperature sensors, to intelligent HVAC systems, to many other different systems that allow us to actually understand the physical world and build a digital twin around it, and with that digital twin allow us to more effectively decide when we maybe switch on an HVAC system. What that specifically means, though, if I say smart, it's kind of that initial stage of sensors, data capture, what's going on, what's my physical world doing, metering, how much electricity am I maybe consuming, do that in real time and integrate that into past performances, right? Basically look, how many people were in my building in the past, now compared in real time what's happening. And that allows you to then use intelligent services, think analytics, think machine learning, or AI if you prefer that word, and then model around, predict what my demand would be, and then make my buildings smarter, and I'm also visualizing that. If we take that as a bit of a step-by-step, colors came a bit out wrong there, but basically if you think about it, it's multiple levels of the building. If we start off, we connect the building, we install sensors, we understand what's going on, we make it then intelligent. From there we can make smarter decisions, build analytics services, and model around what we're actually using and consuming, all the way to a complete self-aware building. Everything switches on and off just based on analytics, based on machine learning, based on what we actually sense in that physical world. And when we talk sensors, one of the things that we probably think of is things like temperature sensors, electricity consumption. But what about cameras? Cameras are often installed in many different buildings, and cameras can be a great resource for us to build intelligent buildings or smart buildings. Take, for example, we recently announced something we call AWS Panorama, which is basically a small little ruggedized box. You can see it here on the slides, which is like a 1U factor. But what it allows you to do is you can take your existing IPTV, CCTV cameras, you plug it into this box, and now you have computer vision that you can run on top of your existing cameras. Why would I run computer vision? Well, now I can get insights, for example, on how many people are somewhere and how people are moving around. Actually, some of our customers use it for workplace safety. They're using do people keep their social distance, for example? There are many different ways of using computer vision to make your building more intelligent. The key point is you can retrofit this in. You don't need to buy the latest and greatest camera. A device like this can take an existing camera and make it smart. In a similar gist, if we think, for example, about HVAC systems, right, or just in general, especially in manufacturing others, you might have a lot of different generators, pumps standing around. A lot of these might not have or have not been equipped with sensors. So how do I make them smart? Well, there are different ways of doing it. One example is, for example, Amazon Monitron, but of course also with the Smart Energy Connect platform here that we hear a little bit more about later. Many different ways of actually retrofitting equipment, making it smart. Monitron is, for example, an example from Amazon where you can just attach sensors to it, have a gateway, and then, for example, do predictive maintenance, understand when pumps are maybe about to break or if they consume too much electricity, etc. And also other services that do it with existing scenarios. We talked a lot about smart buildings, and we hear more about that later, but I wanted to give you a few other examples also from customers that try to be more sustainable in a different industry by using data, by using intelligence. Take, for example, the airline industry. One of our customers called Qantas, which is the Australian national airline. They were looking into how can we actually reduce the amount of fuel that we're burning through and improve our flight plans that we have. And the idea here was, again, lots of different data that you collect, weather information, flight path information, engine, turbine information, etc. They bring that to AWS and then run simulations. And that flight path simulator allows them to find better flight paths and actually reduce up to 50 million kilograms of carbon emissions yearly just by doing that. That's really the power of data. Or take something straight down to the consumer, and I just wanted to take another example here. That already happened in 2013, where we had, for example, British Gas, which went ahead and said, well, could I build a mobile application to remotely control water and heating and they allow them to, every household, save up to £150, which obviously, in an equal manner, reduces the amount of carbon footprint that we emit. Bottom line is, you probably want to build an intelligent platform. You know, you want to make use of data. You might have heard of things like data lakes and machine learning and analytics. This is obviously where your cloud computing provider will be useful. AWS is here to help. Smart Energy Connect platform is here to help with CLP to build intelligent systems on top of your cloud computing provider and reduce the amount of carbon footprint that you have. That's all I had to cover for today, but I think we got still time for a variety of questions and answers. Thank you.
Great, thank you so much, Olivier, for the fantastic sharing from AWS. And well, before we have some questions for Olivia, just a reminder for everyone, if you have any questions, remember to click the question mark icon on the top right-hand corner and then select the Q&A sections. Type your questions inside the message box. Remember to click Start Chat, that button, to submit your questions. Okay, here we go. We actually received a few questions for Olivia. And to start off with, the first question, it's, are all systems required for an intelligent building need to be cloud-based? And what are the security concerns associated with it?
Yeah, that's a great question. So when we talk about cloud computing and AWS specifically, we have a variety of different options. So obviously for a lot of services, you might run them in what we call AWS regions or AWS local zones, which is the managed environments or data centers that I talked about earlier. But we also have the ability to do what is often referred to as edge computing. So we have a variety of different services that allow you to run some parts of the services that AWS provides within, you know, what we call outposts, actually physical machines that you can rack and stack in within your own facilities, or fully managed services that you can run at the edge, meaning in your own facility. So we actually, if we think about smart buildings, that's probably the way we want to address it. Some of the logic will probably sit in a basement somewhere of the building itself. That can run on something like what we call AWS Outposts, which is actually hardware that we provide to you. You can put in the basement of your building, have some intelligent run there, and then bring some of that data back into your cloud environment, where you probably want to run your analytics and machine learning, get great benefits from doing that. So long story short, the bottom line of it is you have full flexibility around where you want to run your services. We provide you flexibility around saying, of course you want to run in the cloud computing environment wherever it makes sense. If for whatever reason you have latency constraints or you have intermittent network connectivity, you can also run it at the edge, meaning in your facility, in the basement of your building, for example, as such, and have as such also control of the security element as such.
Thank you, Olivia. And actually, there's for the second question, one of the audience asked regarding during your sharing, you mentioned about the AWS Panorama. Mm-hmm. They would like to know: is there any concern regarding the privacy?
Yeah, so this is always a great question. And from an AWS perspective, of course, we provide our customers full flexibility and choice on how they store and handle their data and full control of it. But I think generally we talk about privacy or security. I think the nice thing about going digital, nice thing about using cloud computing is you have full granular control on how data is stored, how data is encrypted. By the way, with AWS, by default, everything will be encrypted at rest. There's actually no option to not encrypt data. That is the default. You're in full control as a consumer on how you handle that data. There are also a variety of different services on how you can, for example, remove maybe personally identifiable information or mask a variety of different data sets that you have. So again, it goes down to what kind of targets, security or privacy requirements or targets you have, and our platform allows you to adjust it based on that and say, you know, I want this to be obviously encrypted, I want it to be masked, etc. Only certain people can access it. That's exactly what we encourage. And of course, if you ever have questions around that, our team is more than happy to help to find the right approach for you there.
Thank you, Olivia. Well, for the next question, it's is AWS using VPPA for achieving 100% RE, and is there any case that you can share with us in the Southeast Asia?
I'm not entirely sure what the VPPA acronym stands for, but I take it as a question around Renewable, yeah. So, okay, got it. So if we talk about renewables, actually, so we run a variety of different projects all across the world. If you go to our AWS website, you actually find our sustainability initiatives, and you find an entire landscape or a map where we run these renewable projects. They're primarily around wind farms and solar farms. A good chunk of that is currently mostly in US and Europe. You'll find that across Asia Pacific and India, China, we run a variety of different projects. And to get to our target of 2025 of running 100% renewables, of course we keep expanding that. But yeah, if you want that person who asked it, if you want the specific details, we got a very nicely fledged out map on all our 127 different projects that we run across the world. Just look for AWS sustainability and you find a map on our website with all the details.
We still have one more question lining up. It's regarding IoT solutions. It's a great idea for new buildings, but how easy it is to retrofit inside an old building?
Yeah, that's again a great question. I think it's if you look at that map that I kind of showed in terms of step by step on how you make a building slowly intelligent. If you build a new building, of course, great, we can put in the latest and greatest. The reality is most buildings need to be retrofitted. If you have existing systems where you have, some OSI or whatever software that reports some data in, you can easily integrate that. But even with the few examples that I showed with things like Panorama, Monitron, Amazon Lookout, or other things, you can easily take existing equipment, retrofit your cameras, make your buildings slowly intelligent, step by step. And that is actually, if you look at our customers, that's obviously a lot of customers do exactly that. They don't just go out with a big bang, but they do step by step, looking into how do I make my building smarter. After I connected it, after I understand the data, I can slowly make decisions. I can install actuators, maybe into my HVAC systems, etc. And of course, have Smart Energy Connect platform maybe to help me out with that more.
Great, thank you once again, Olivier.